Good morning, students. So today we will be discussing about the architectural design, which is again a part of a third unit. Right? So what do you mean by an architectural design? Architectural design is like an overall framework, you can say. Like for example, let's go for we go for chatting. So during the chatting, the architectural pattern is or overall design is a client server architecture. So with this example, that will be clear that whenever you're going to develop any system, it has to be based on certain framework that is known as architecture here, right? So there are several architectures we'll be discussing today. Prior to this, we must know two terms, that is what are architectural views and what are architectural patterns, right? So to continue with that, first of all, what is software architecture? The design process for identifying the subsystems making up a system and the framework for subsystems control and communication is a architectural design. So architectural design is nothing, it is the overall framework where it represents the subsystems and the communication and controlling all those communication between the components is known as architectural design, as well as the output of this design process is known as software architecture. Okay. Now what is an architectural design? An early stage of the system design process, right? That means before making the detailed designing, like whether it is object oriented or function oriented approach, we first of all make a architectural design, that is the overall framework. It represents the link between the specification and design process. Okay, fine. Often carried out in parallel with some specification activities. Like it says that architectural design is also a part of specification, that is requirement phase also. Like in SRS document, the overall block diagram or the architecture on which the system is based is developed in the SRS also, right? So it is in parallel with the specification activities. It involves identifying major system components and their communication simply. What is the use of these architectural design or models? First one is it helps us in facilitating the discussion about the system. Now the customers and the developers, right, they have to discuss. So this is one point which helps us, since it is a diagrammatic way, overall structure of the framework is represented. So a better understanding of the system can be achieved and we can have the discussion based on this approach, as well as this also helps in documenting our system, right? So these are the two basic benefits. Now what are these architectural views? Architectural views are basically, you can say, we have 4 plus 1 view model of a software architecture. Now what are these views? See, the first view is a logical view, second is a process view, development view and a physical view. So what do you mean by a logical view? Logical view of system, which shows the key abstraction in the system as objects or object classes. So logically, how you have divided your system into entities, that is the classes, are being represented with the help of a logical view. The process view represents the runtime behavior of your system. Okay, how the process are going to interact with each other while you're executing it. That is a process view. Development view represents the software. Like we divide our software into submodules, modules and submodules. So this development view shows the system how the software is decomposed for development, while a physical view, as the name suggests, it shows the system hardware and how software components are distributed across the processors in the system. Physically means how different components are being, like you can say, how they are being used, like hardware interfaced for the purpose of, and you can say, using the system properly. And the last one, this plus one, is related to the use cases or the scenarios. So just to remember, these are the 4 views. Basically, you need to remember logical view, that represents your objects in the classes. Process view represents your runtime behavior, how the process interacts with each other. Development view, how the system is decomposed for development, and a physical view shows the hardware and the components, how they are being interfaced. Then coming up to the architectural pattern, which is important. Architectural patterns are a means of representing, sharing, and reusing the knowledge. First of all, the framework is being made. That means you're presenting your system. You're sharing the information with others, right? It is a way of facilitating discussion as well as reusing the knowledge. That diagrammatic approach helps us in extracting the knowledge and use for our purpose, right? So that is a pattern. An architectural pattern is a style description of good design practice which has been tried and tested in different environments. That means it is a good practice. We must always go for making an architectural pattern. Pattern should include information about when they are and when they are not useful, right? So whenever you go on making a pattern, since we have 4 patterns, so we must know what is an application area for each pattern. It's not necessary that all 4 patterns can be made for each and every application or the project. So it must be clear where to use the one and where not to use a one. Patterns may be represented using tabular and graphical description. So we'll see both the descriptions now, the graphical way also as well as the tabular way also. So there are 4 architectural patterns I said. The first one is a layered architecture where the system is arranged in layers. Second one is a repository architecture where we have a central repository and the components of the system are interfaced or linked with the central repository. Then the third one is a client-server architecture where the servers are there, the services are being provided by these servers, and we have clients who are going to use the services provided by these servers. And the fourth one is a pipe and a filter architecture where the sequence of activities to be carried out in a say transaction processing system are being represented with a pipe and filter. So pipe represents the sequence of activities and filter represents the conditions applicable. Say you have to follow one particular direction, not the other one, so condition would be there, right? Let's see all these in details now. The first one is your layered architecture. It is used to model the interfacing of subsystems, right? That means our system is arranged into layers and it shows the interfacing among those subsystems, organizes the system into a set of layers, abstract levels, supports the incremental development of a subsystem, right, in different layers. However, often artificial to structure system in this way. Let's come up to the point. So prior to this tabular form, let's see the diagrammatic way. This is a generic layered architecture. Now it will be better clear that the entire system has to be organized in the form of layers. This is layer 1, 2, 3 or 4, right? Now what is at the top is the interface, user interface. Whenever you develop any system, you have to provide the interface. User is going to interact your system from the top. So we must have a user interface here, like browser. Browser is a user interface which helps us to access the web. So similarly, we are saying it's any application and interface is a mandatory thing. Once the interface is there, then we have user interface management layer. That means it's not that all users will be using the complete system. Right? They must be authenticated users. That means they have the login credentials. They can only use the system. And not all users have the same rights. They are being authorized for different access rights are being given to them. Based on that, they can use different functionalities. So that is authorization. So this manages who are users are authentic and who are authorized to use a particular functionality. Then comes the core business logic or the applications or the utilities are developed here. The system that we actually develop. The major functionalities are present in the third layer. While the fourth layer is system support layer, that is which constitutes of operating system and the databases, which is. So what is the purpose of this layered architecture actually? Why we have divided this into layers? That means what we have done, the set of related functionalities are kept under one layer, right? All the functionalities related to this are being placed here. All the business logics are being placed here and all the database and OS has been, which is. So what happens in a layered architecture is the lower layer provides services to the layer above it. This layer provides the services to the layer above this. This layer provides the services to the layer above this. We know that whenever you are working on a system, definitely we need the database. Either we need to store our information or we need to fetch it. So lowermost layer is this, where the database is present. So we can store our information here or we can fetch it here. So this is the basic part where the entire information is present. So now let's see, based on this architecture, now see what does it mean. First, as a description, it organizes the system into layers with related functionality associated with each layer. A layer provides services to the layer above it. So the lowest layer represents the core services that are likely to be used throughout the system. Okay, fine. Then, in example, a layered architecture of the system for sharing copyright documents held in different libraries. Leave it. When it is used when building new facilities on top of existing system. So what does it mean? Say I want to add new features of functionality to the existing system. So I can create one layer above it and I can add the functionalities in a new layer without disturbing the existing system. So when the development is spread across several teams. Now layered architecture is again used when we can divide our layers into different teams. Say team 1 is going to prepare user interface, team 2 can prepare this management part, team 3 will prepare this logic part, and team 4. So we can divide the task into number of teams, right? Then also this layered architecture is a good way. Okay, fine. Where there is a requirement of multi-level security. The third thing where we require this, third you can say application area, is when we require multi-layer of security. Multi-layer of security means, for example, say you have a bank account, you have your login ID. Okay, so once you enter your user ID and your password, you get logged into your system or the bank account, right? This is one level of security which is provided at the abstract level. But once you go for any transaction or online payment, you are supposed to enter your transaction password. Along with the transaction password, you also sometimes few banks offer this functionality. You have to enter the OTP which is being sent to your mobile, right? And it has a particular time span. Say for 30 seconds, it is valid, the OTP. Or you have a grid password. So there are number of securities which are applied at different layers. So I said login ID. Okay, fine, it works here. The password management. Okay, we have. You can say a captcha provided there, you need to enter that also, right? Then I said transaction password for the functionality. Say you want to go for any, like, and if you want to refer in a database, there might be another level of security which is required to secure your database. So different security mechanisms can be applied at different layers. So when the security is one of the concern, then layered architecture can be used. Now advantage. It allows replacement of entire layer so long as the interface is maintained. That means, say I want to replace this layer. So it is possible. I want to modify it or I want to add new management process, algorithm might be changed or something might be changed. So it is not going to interfere with the other layers. You can directly prepare a new one and you can replace this layer and interface could be developed with the existing parts. So advantage is this, entire layer can be replaced. Redundant facilities can be provided in each layer to increase the dependability of the system. Redundant facility means authentication can be given at different layers also. It's not necessary it is a part of a single layer, right? Then what are the disadvantages? Since every you can say everything that exists has certain pros and cons, right? So advantages are many. Now let's see what are the disadvantages. In practice, providing a clean separation between the layer is often difficult, and a high level layer may also have to directly interact with the lower level layers rather than through the intermediate layers below it. Okay, fine. What does it say? Now we are saying, okay, fine, we have divided all the user interface related functionalities are a part of layer 1. Then management will be a part of. Now to differentiate, because all the functionalities are related to each other and they share we know that interfaces also are the parameters. So clear-cut distinction, this boundary, actually there is no gap, there must be overlapping practically, right? So it is very difficult to segregate these functionalities into layers. They might be interrelated or might be used at different locations. The second disadvantage is we say that the lower layer provides the services to the layer above it. Now say this user interface layer directly wants the services of this OS or the database, right? So how it is done practically is it has to send the request to this layer, then to this layer, then to this layer. And the services back will be provided to this layer, then to this. That means intermediate layers are getting involved. So unnecessary we are wasting the time passing the request from these intermediate layers and response is also given through these intermediate layers. There is no mechanism to like one layer can directly interact with the lowermost layer, skipping the layers in the middle. So again, more time and cost will be required here. Third one, performance can be a problem because of multiple levels of interpretation of a service request as it is processed at each layer. So performance will be an issue. Why? Say I want to use the database. If I directly go on using it, so I'm storing something or I'm retrieving something. So there is no way that the interpretation could be different. But if I'm passing on the message from one layer to another, then to third one, then so the you can say the message could be modified. Like if I directly interact with the students, what I want. So it's good, it's well understood also what I want to say, they are getting that only. But if I pass on to message to CC and then to some other person, then to the fourth person, then finally reach the nth person which I want. So in that way, while I'm passing this message from one person to the another, it might get modified during the process, right? So performance could be one of the issue in a layered architecture. So finally, just it's a simple architecture, right? Used layers has been organized here. We have different functionalities. Lower layer provides the services to the upper layer. When it is used, when building new functionalities, right? Then multiple teams are there to develop each layer's functionality, and we require multi-level security. Three major, right? Advantage: we can replace the entire layer. Redundant facilities can be used at different layers. While the disadvantages are clean separation is very difficult. Now, if I want to interact with the lowermost layer, I have to pass the message to the intermediate layer. That is one of the problem. I cannot skip the middle one, as well as there will be the performance issue. So thus, this is a summarization of the layered architecture. Now let's see an example for a library system. This is what an architecture that is being developed for online library. Why online library? Because I have used a web browser interface. That means web indicates it's in online. If it is simply a library system, not online, I would say it is a browser interface only. But if it is online, you'll just name it properly this. Now the second layer is a user management layer. User management, that means login facility will be provided. Now some users don't want to log in, they simply want to file a query and get the response back by filling a form. So that is also possible here. I want to directly print something, so I can print it without logging into the system. So that depends upon how the user is going to use your system. So that is provided here. The third is the core business logic layer or the utilities. So what are the features of an online library? We can perform a distributed search. Why distributed? Since it is online and the information is present at different locations. So instead of search, we are writing it as distributed search. Then document retrieval could be one of the function. Rights manager, that means say if a admin login, the rights will be different. You have to code it. Access rights given to different users. So this is what is maintained by this rights manager. To a student, the rights access right will be different. For an employee, the access right will be different. So that is developed here. Then accounting, obviously we have to maintain the stats complete. Now one extra layer is added here since the database is distributed. So it becomes very difficult to get the information or understand it. So we are providing an index, library index, where the index will be provided. Okay, this information is present as data one, another information in database. So it would become simple. So this is one of the examples for library system. The layered architecture is being developed here. Now talking about the second architecture, that is a repository architecture. So what do we mean by a repository architecture is, we have a central repository, right? The example that is taken here is a project repository. So whenever you go on preparing a project, we have IDEs, integrated development environment. So this is one of the integrated development environment where these different what are these? These are the, you can say, components, right? They have been integrated with the help of a central repository, right? So software development tasks are many. We have analysis task, we have designing tasks, like we have a design analyzer, we have design translator, you have UML editor for making the diagrams, right? We have code generator to generate the code directly, or we have an editors if you want to write your code, right? Python editor. So multiple tools are being integrated with the help of a project repository. So the complete information of the project is present here. Whosoever is working on this project, he may store the information here or retrieve the information here, right? They cannot directly interact with each other. So everything is centrally placed here and everyone can access the information from here. This is a repository architecture. Now see, description. All data in a system is managed in a central repository that is accessible to all system components. Components do not interact directly, only through the repository, right? Now, second one, example, this is for a project repository, fine. When this architecture is used, you should use this pattern when you have a system in which large volume of information are generated that has to be stored for a longer time. So it is clear repository architecture will be used when you have voluminous information and that has to be stored for long duration of time. Like projects work for, like development takes years and they are being used throughout their entire life. You have to store and maintain that information for so long, right? That is why we took this example. Now you may also use it in a data driven system where the inclusion of data in the repository triggers an action or a tool. So we have done data driven, event driven and data driven. Remember the insulin pump control system? So that insulin pump control system was a data driven, right? So the data which is generated triggers the next process. Then some data is generated, it triggers the another process. So in that case also, we are saying repository pattern is going to be used. Now what is an advantage? Components can be independent. They do not need to know of the existence of other components, right? Since they are linked to directory or repository only, so they are unaware that other components exist, while they all are working in parallel with each other. Changes made by one component can be propagated to all components, right? See, what exactly is this? If I say in Graphicera, right, the entire information of the students are present in the information cell, right? Information cell or has all the information. Now, why we go on registering the student in each semester? Why? Because the information which is present in the information cell, that was generated while they took the admission. Now meanwhile they reach a second year or third year, maybe their address changes. It might happen, right? Their mobile number could change. So we keep on, like, though central repository is good, but it's not necessary it is updated always, or you have to update it at the centralized location, right? And whosoever wants the information of that student don't have to look for the department or the class or the faculty for that. Directly go to the information cell and you can get the information. So entire information is updated in the central repository, right? And changes made by one component can be propagated to all component. All data can be managed consistently, right, as it is all in one place. So the redundancy will be reduced as well as it will be consistent. I said an example of information cell. But what is a major disadvantage? This architecture has one major bottleneck, that is a single point of failure. Single point of failure, say, if this project repository crashes or fails, the entire system will go down, right? It is an halt to the complete system that is under development. So this is a single point of failure. Maybe inefficiencies in organizing all communication through the repository. Since you are going to communicate through this repository, so inefficiency could be there. If you go on interacting directly, maybe a better results could be obtained. Distributing the repository across several computers may be difficult. So single point of failure, if you're trying to distribute it, it becomes a difficult because you have to maintain the interfaces and everything, right? So this was all about your repository architecture. Another one is a client server architecture, which is known to everyone. We know that in a client server architecture, this is a distributed system where we have servers which provide the services, and we have clients who are going to use these services, and the net connectivity is a mandatory thing which is required here, right? Now, what is the client server architecture? Here we have taken an example of a film library. We know that you can view the films, movies online, right? And the online movies are present at different locations. If you keep them at a centralized location like repository architecture, so the traffic will be more. Since the entire information would be present at a single location only, everyone is going to send a request and try to view the information. And the single point of failure was one of the major disadvantages. So what we try to do here is we are trying to distribute different or distinct services to the different servers. For example, a catalog server. We have taken 4 servers here. A catalog server where the library catalog will be present. A video server where all the films will be there. A picture server where we have all the photos stored there. And a web server which has the information of all the films and photos. So 4 different categories of functions are present here. So we have made 4 services, right? Then we have what is mandatory thing is an internet connectivity required, and we have different clients. So whosoever wants to view a particular information, the traffic can be distributed because maybe a person is requesting for this. So it's not mandatory he is also looking for the same information. It might be, right? Probability is there. But it's not that everyone is going to view this only, so the traffic will be diverted to this server only. Some might be looking for this, some might be looking for this, some might be looking for this. So we are distributing our task upon different servers. So that congestion problem can be resolved here. That was a problem in a repository architecture, as well as the single point of failure is also resolved here. Since you have distributed it, say one of the server is not working, so the services of this server won't be available at this moment of time, while the other servers are working properly. These are available to the user. But there is one problem associated in this architecture is this net internet. The connectivity issues could be there. So what are this? In a client server architecture, the functionality of the system is organized into services, with each service delivered from a separate server. Clients are users of these services and access servers to make use of them. Fine. Example, this is there. When to use this architecture? Used when data is shared in a shared database has to be accessed from a range of locations. Geographically, the users are far apart and they want to access the information. Because servers can be replicated, may also be used when the load on a system is variable. We can replicate the servers also depending upon the demand. Now, what is the advantage? The principal advantage of this model is that servers can be distributed across a network. Generally, functionality like printing services can be available to all the clients and does not need to be implemented by all the services. Fine. What is the disadvantage? Each service is a single point of failure. Not the entire system, we are talking about the services. So one server could be a single point of failure for the services that it provides. So susceptible to denial of service attack or server failure. Performance may be unpredictable because it depends upon the network, right? Connective issues. Maybe management problem if servers are owned by different organizations. Okay, the servers could be owned by different organizations, not one. So there could be some management issues present in this. But yes, overall, this is a good architecture that is being utilized in major applications which are being developed. The last one is a pipe and a filter architecture. Pipe and a filter architecture is this simply. We are representing a transaction processing system, the invoice generation process actually in a store. departmental store, you can say, right? Say a departmental store is there and a number of processing are there. Okay, fine. What is the main task which is being represented here is we have to issue invoice, right? So what we do is understand the process first of all. There is a database represented with this. These are the process and these are the arrows, that is the connecting lines. Now we need to check on the monthly basis uh, whosoever has made the payment, right? So we'll check the read issued invoices from where? From the invoice store, right? Once you read it, invoice, then you identify whether the payment has been done or not for that particular invoice is a bill, right? So we'll check from the payment store. We'll try to identify the payment, status of the payment. Now, if the payment is already being done, right? So you have to issue a receipt. Issue a receipt for this, right? And that receipt which is being generated is stored in the receipt store. This is one set of activity. Why? If the transaction like or the payment status says the dues are still left, so what we'll do, we'll identify, find the payment dues, how much dues are there, then issue a payment reminder to the user, and those reminders will be stored here. So ultimately, what do we mean by pipe and filter architecture? What is a pipe? Pipe are these sequence of activities. This is what a pipe is. And what is this filter? Filter is like this step. We are identifying the payment. If the payment are done, we go for this pipe. And if the payments are not done, we follow this pipe. So it is acting as a filtering step, right? So this is pipe and filter architecture. So description, when do we use it? The processing of the data in a system is organized so that each processing component, that is filter, is discrete and carries out one type of data transformation. So each step is acting as a filter and it is performing some type of data operation or transformation. The data flows as in a pipe from one component to another for processing. So data is getting flowing from one step to another, another to another, like this way, right? Example is for a processing invoices here. When to use the system? Commonly used in data processing applications, which can be of batch processing system also. It can be a transaction based system also, where inputs are processed in separate stages to generate related output. So these were the filtering steps or the stages. What is the advantage of this model? It is easy to understand and support transformation reuse. Workflow style matches the structure of many business process. This is what the step is followed in maximum all the business applications. Evaluation by adding transformation is straightforward. If you want to add something, that can be easily added at next step. Can be implemented as either in sequential or concurrent. Okay, fine. Sequential is also, concurrent is parallel. So this is sequential. These are parallel activities. Disadvantage. The format for data transfer has to be agreed upon between communicating transformations. You have to stick to one particular format, right? Each transformation must pass its input in and pass its output to the agreed form. This increases system overhead and may mean that it is impossible to reuse functional transformations that use incompatible data structures. So major thing is that must be compatible in nature. If it is not, then it increases the overhead and it increases the complexity finally. So this was all your design patterns. Thank you for today.